Hello everyone, let's discuss question number 13 of test 1. So the question says, discuss normalization methods. First is min-max normalization, second is z-score normalization, and third is z-score normalization using mean absolute deviation. And fourth one is decimal scaling. So let's discuss them one by one. First is min-max normalization. This method converts a value into fixed range, usually 0 to 1. It keeps that relationship between values but rescales the data. Formula for calculating is x dash is equals to x minus mean upon max minus mean, where x is original value, min max are the minimum and maximum in that column, and x bar is a normalized value. And here we can see the example. We have given the values 10, 12, and 30, and normalized is 20. Uh, Normalized is 20. So calculating on putting the values in the formula, we have got answer is 0.5. When we need, when we use this normalization method, when we need the data in fixed range from 0 to 1 like neural networks and distance-based models. Second is Z-score normalization. Uh, this method shows how far a value is from the mean in terms of standard deviation. It centers the data around 0 and gives standard deviation 1. Formula is x minus mu upon sigma, where x is original value, mu is the mean of the column, and sigma is the standard deviation. Uh, let's take an example where value is equals to 25 and mean is equals to 20 and standard deviation is 5. On putting this value in the formula, we have got the answer as 1. When we use this method, when the data has outliers or value needs to be standardized. Third one is Z-score normalization using mean absolute deviation. Similar to the normal z-score, but instead of standard deviation, it uses mean absolute deviation, which is more robust to the outliers. Formula is x minus mu upon mean absolute deviation, where mean absolute deviation is 1 by n summation xi minus mu I. Why it's better? Standard deviation gets inflated by large outliers, but mean absolute deviation avoids this. Let's take an example. Here we have given the values 10, 12, and 10, 20, and 30. Mean is 20. So we will calculate the first mean absolute deviation. On putting the values, we have got 6.67 mean absolute deviation and normalized as 30. Uh, on putting the values in the formula, we have got answer is 1.5. Now the fourth one is decimal scaling. Moves the decimal point of values until all values fall between -1 and 1. Formula is x dash is equals to x upon 10 to the power j, where j is number of digits in the largest absolute value. Let's take an example. Values are 120, 45, and 7. Largest is 125, which is from 3 digits. So j will be 3. On putting the value in the formula, we have got the answer 0.007. When we use this, when scaling needs to be extremely simple. This is all about question number 30. Thanks for watching the video.